In this tutorial, we'll take a look at how we can match STL files such as intraoral scans with 3D volumes. For the matching, we will use this fit model function here. In the earlier versions, this was in the upper toolbar, but now in version 6, we have moved it here in the toolbar. So let's activate the function. In the dialog that gets opened, we have the surface model of our 3D volume here on the right side. We can manipulate it with our right mouse button. We could also use these orientation buttons here in order to view it from different directions. To the left side, we can bring our STL file. If we haven't captured the STL file directly to Romexis, or we haven't yet imported it, we could browse for the STL file in our computer file system through this browse button here. If the STL file is already inside Romexis, so we have directly captured or imported it for the patient, we can click here on the select, and we will get a list of all the surface models of the patient. So we can pick this intraoral scan here and click OK. Also this one we can manipulate with our right mouse button. So the general idea for matching is that we would be picking 3 common points in both of these data sets, and then there's also an automatic algorithm that optimizes the matching based on those 3 points given. For picking the common points, it would be good to have as much data as possible, so we don't always have a full denture 3D volume like here, but at least it would be good to have an intraoral scan that covers at least all the teeth that are visible in the CBCT volume. Before picking those points, we could use these cropping sliders here. So if we're matching just the maxillary model, for example, like here, we could get rid of part of the volume if that helps us. And another slider that we can use is this threshold slider here. So with this one, we could remove artifacts, but then on the other hand, we would need to be careful so that we're not actually losing the bone surface based on which we would be looking for the common points. So first we'll look for a point here in the intraoral scan, and then for the respective point in the 3D volume. In order to improve the accuracy of the matching, it would be good to select those 3 points far away from each other, and maybe also from different sides of the scan, so that they wouldn't be all on the same side and they wouldn't be all on the same line or on the same 3-dimensional plane. So we could, for example, pick the first point somewhere here. So we're selecting the points with our left mouse button, right for manipulating the models, left for picking the points. So the first point is red, and the second one is green and has a different shape. At any point, if we would like to remove the points, we could use this arrow here, so that would remove the latest point. And always when we are positioning the points, we could re-click here in order to adjust the positioning of the point while we are placing that point. So still a third point. After placing 3 points, we will get this initial matching of the STL file on top of the 3D volume. And also here we see the number of points given, and if the background here is green, that indicates that Romexis agrees that these points correspond to each other, so we have made a good selection. If here we would see the background in yellow, that would mean that there's probably a little bit of deviation, but the matching might still be okay. If the background is red, then maybe we have placed the points on different teeth on both models or something similar, and maybe also we wouldn't see this preview here at all in place. At this point, we could actually continue adding the points up to 10 points. So that's also an option if we aren't happy with these 3 points and the automatic matching algorithm. When giving more points, it might be better to deactivate this automatic matching algorithm, as that might not then improve the matching result. So the options that we have here, this would allow Romexis to scale this STL file. This is not usually needed. Then this automatic matching algorithm is selected here by default. And if we wouldn't like to match the STL file through this dialog, but we would just like to import it here in the plan and then maybe manipulate it in place manually, we could tick this option here. Especially if we're matching several STL files, we could select here whether we are matching a dental model or crown, and then also we could specify whether that belongs to the upper or lower jaw. So this information we would see then in the object browser next to the fitted models. So after giving this minimum of 3 points, we're ready to continue the matching. So let's apply the automatic algorithm by clicking on Done. After the algorithm has finished calculating, we can verify the matching result with the color map. So now we could, for example, use this threshold slider in order to hide the 3D data, and we could just examine this intraoral scan. So here these colors indicate common surface found between the intraoral scan and the 3D volume. So green means that the common surface was found, and usually we would like to see that on crowns because crowns would be the same data in both the 3D volume as well as the intraoral scan. Instead, soft tissue we would usually like to see in red because that's something that we only have in the intraoral scan, and that it's not visible in the surface model of the 3D volume. So of course there might be some artifacts, and the crowns wouldn't always be perfectly green, but with this one we can get an idea of how accurate the matching was. So if we're happy with this matching, we can click here on Use Automatic Match, and if we would like to retry, we could click here, or then we could restart the whole process. So now the intraoral scan gets matched here in the 3D volume. We could use the same function if we would like to import, for example, an individual virtual crown design. So this time we would select the crown model. So this here was an individual crown that was designed in our CAD/CAM module, and we could use it to assist us in placing the implant. And Romexis automatically finds the right position for this crown because it was designed on top of the same intraoral scan. So they remember their mutual coordinates, and we could just click on Use Existing Match and it would be placed here correctly. Before continuing to implant planning, for example, we could still verify the matching of the intraoral scan by checking the outline of the scan here on the slice views. So we could browse here through the 3D volume stack, and we could verify if the outline of the intraoral scan follows the crown surfaces in the 3D volume. We could actually manually try to adjust the positioning of the intraoral scan. So by default, these fitted models get locked so that we don't accidentally move them, but we could, for example, release the locking of this intraoral scan by selecting it and by clicking on this lock icon. So now it's movable in the plan. Let's still deactivate this one. And then we could grab the scan with our left mouse button and we could move it. So left mouse button for moving, and then with the right we could rotate it. For moving the scan, we could also open these properties here in the object browser. So this wrench-like icon, and here we see a tab Move, where we could specify the rotation in degrees in all 3 dimensions, as well as the translation in millimeters in all 3 dimensions as well. So we could be using these controls here. However, remember to check that after these adjustments, the matching of the scan looks okay on all sides, because adjusting it somewhere might affect the matching on a different side of the model. If we would like to cancel these manual adjustments, we could click here on Reset to Original Position, so it would be reset to that position where it was after matching. And after moving the scans, remember to lock them again so that we don't accidentally move them with our mouse. We can manage these fitted models here in the object browser. So like we saw, we could use this eye icon in order to hide or show these models in the plan. Then this arrow indicates to which jaw the different fitted models belong. So we could change this for the crown. So we could just click once here in order to indicate that it belongs to the upper jaw. So this is just for ourselves to understand better where different fitted models belong if we would have a long list of them here. Also here we could change the color by selecting this color box here. So now our intraoral scan turned white. Also if we would like to delete these fitted models, we could select all those models that we would like to remove and then use this trash can icon here. And finally, we could also modify the comment for these fitted models. So if we open again these properties, we can go here to this gentle model and we could give a comment. So this might also help us in understanding which fitted model is which, if we have several ones here in the object browser.